Yeah, good day viewers. Yet again is Access Point Academy video lecture series. Now we have equilibrium quantity and equilibrium constant. So in this question, we are to unravel, we are to solve this question. And the question says nitrogen gas reacts with hydrogen gas in the manufacture of ammonia, NH3. Okay, so we have the equation of reaction. Thereafter, we have 3.28 moles of nitrogen and 6.64 moles of hydrogen were mixed together in a container of volume 2 dm3. Now, at equilibrium, 1.76 mole of ammonia had reacted. And the first question says we should calculate the equilibrium amount in mole of nitrogen and hydrogen. Then also we have to calculate the equilibrium constant. So now, how do we write that? How do we solve that? How is that meant to be unraveled? Now we write solution. So we want to justify, we want to answer that question. Now to do that, the first thing, we need to write out the equation as it is given in the question. We have nitrogen gas reacting with 3 moles of hydrogen gas in a reversible reaction to give 2 moles of ammonia, NH3. Now very essential, we need to write the mole ratios. So the mole ratio here is 1, 3, then to 2. And that is the mole ratio. Now in solving question that has to do with equilibrium quantities, now it is very essential we use the format which is ICE. So you write down the initial. I stands for initial, C stands for change, YE stands for equilibrium, all in moles. So now the first thing we're gonna write is the initial, that is the initial mole given in the question. Now the initial mole given in the question is for nitrogen gas is the 3.28. So we're going to write 3.28, that is for nitrogen, and 6.64 mole for hydrogen, 6.64 moles. So we have nothing for ammonia, so we represent that as 0 or nil. Now as the question proceeds, the question says at equilibrium 1.76 moles of ammonia had formed, that is at equilibrium. Okay, 1.76 mole of ammonia, that is in our right equation for the equilibrium. Also you write the value for the equilibrium. We are only given the value for the equilibrium of ammonia, so you write it here, that is 1.76 mole. So now how do we get the change? Okay, now next is to write change, also a mole. Now how do we get the change? So we get the change by subtracting the equilibrium from the initial mole, or the initial mole from the equilibrium. So this is 0 minus 1.76, so that will be 1.76. So that is the change for ammonia gas. Now next is to get excuse me, the change for nitrogen gas and hydrogen gas. So how do we go about that? Now we have to use the mole ratio. We need to compare. Now for the nitrogen gas, okay, for the nitrogen gas, we have that 1 mole is equivalent to 2. Okay, so now the unknown here for nitrogen gas we represent it as X. Okay, for nitrogen gas we represent it as X. So X will be equivalent to 1.76. That is 1.76. So on cross multiplication we find out that our X will therefore be equal to 1.76 divided by 2. So X, change in mole for ammonia, that is going to be 0.88. Okay, so that is the change. So our x is 0.88, so we're going to write 0.88 here. Now after that, we need to calculate the change in mole for hydrogen gas. So we do similar thing as we did for ammonia, for nitrogen rather. So we do similar thing for hydrogen. So what happened, we have to compare, okay, this 3 with this 2. So we say 3 is equal to 2, then the change mole we represent it as y for nitrogen, which is equal to 1.76. So now on cross multiplication, we have that our y will therefore be equal to 3 multiplied by 1.76 over 2. So now when we do that, so we find out that our change in mole for hydrogen gas y was equal to 2.64. okay, so we've gotten the change in mole using this side expression there. Now quickly, we need to get the equilibrium mole. Okay, to get the equilibrium mole, so you need to subtract. So 3.28 minus 0.88. So therefore that should be 2.40. Then you do similar thing for this 6.64 minus 2.64. So that should be 4.00. So therefore the equilibrium mole for nitrogen, and hydrogen gas is 2.4, okay, mole, and also for hydrogen gas is 4 mole. So what do we do next? That is the A part of the question. Now the B part of the question, says we should calculate the equilibrium constant Kc. Now how do we calculate the equilibrium constant Kc? You do not forget that to get our Kc, we write out easily and conveniently using the law of mass action, which is the concentration of those species at the right hand side to the power of their coefficient over the concentration of the species at the right hand side, which is nitrogen gas, okay, multiplied by that of hydrogen gas to the power of its coefficient. But meanwhile, we need to get equilibrium concentration for each of these. Equilibrium concentration, and equilibrium concentration is therefore equal to the equilibrium mole divided by volume, okay, divided by volume. Meanwhile, volume has been given in the question to be 2dm cube. Okay, so we're going to write 2dm cube. That is the volume given in the question. Now we need to calculate the concentration, equilibrium concentration for each of these species, so we can fix them in here. So now what do? Now we find the equilibrium for ammonia, the equilibrium concentration for ammonia. So now the equilibrium mole for ammonia is 1.76. So 1.76 divided by volume, the volume is 2. So equilibrium concentration for ammonia 1.7 divided by 2, that is 0.88 mole per dm cube. Now similar thing is done for the next species there, which is nitrogen. We have to calculate the equilibrium concentration for nitrogen gas. So now the equilibrium mole for nitrogen gas is 2.40 divided by the volume, which is 2 dm cube. So now 2.4 divided by 2, that is 1.20 mole per dm cube. 1.20 mole per dm cube. Okay, so now we do similar thing for the third species there, which is hydrogen. We've calculated the equilibrium concentration for hydrogen. Now, in calculating the equilibrium concentration for hydrogen, so the equilibrium mole for hydrogen has been found to be 4 dm cube. Okay, 4.00 divided by the volume, which is 2. Now, 4 divided by 2, that is 2.00 mole per dm cube. Now, we can now substitute the values we have in here in this expression to get our equilibrium constant, Kc. So therefore, Kc will therefore be equal to the concentration of ammonia, which we have calculated to be 0.88. Okay, so it has a power of 2 on it, so we have to put to the power of 2. Now we need to write the unit as well. So the unit is going to be mole per dm cube everything squared. Okay, mole per dm cube everything squared divided by, so we're going to divide this by the concentration of nitrogen gas, which is 1.2. okay, that is 1.20 mole per dm cube multiplied by the concentration of hydrogen, okay, which is 2. All right, that is 2 to the power of 3. Okay, it has a power of 3 in there. Okay, so to the power of 3. So we also write the unit, which is also mole per dm cube, okay, to the power of 3. So now we can now do simple mathematics. Now let's first cut. Now this, we cancel out 2 of this, so we have only this and this left. We have this and this left. So now in the square of 0.88 is equal to 0.7744. that is the square of that, divided by 1.20, okay, multiplied by the cube of 2 raised to the power of 3, that is 8. Okay, so now we can now write that 0.774 divided by 1.2 multiplied by 8, so everything there is equal to 0.0807. okay, so this is mole multiplied by mole, that is mole square, okay, for the denominator precisely, that is mole square, then dm to the power of minus 6. So now they're going to go up, simple indices here, so the unit therefore will be dm to the power of 6 then per mole square. So it is very, very important you write the one with our negative first, then followed by the one with the negative sign in the power. So it is arranged in that way. So mole, that is mole square, dm to the power of minus 3 minus 3, that is minus 6. So that is the answer to this question. Thank you very much and have a blissful day ahead of you.